Chapter 1, Section 2 is using segments and congruence. Now, whether you remember it or not, you learned congruence in elementary school. How do I know? Because number one, I used to teach elementary school. Number two, my son is in elementary school, so I see it on his side too. So this may be a term you remember, you maybe not remember. So when two things are congruent, they are the same shape and the same size. That's what congruence means. So we're going to hear that a lot. Two things that are the same exact shape, same exact size. Like two triangles that are exactly the same shape, exactly the same size would be congruent. So that's what we're going to be looking at today. All right. So a coordinate is a number that corresponds to a point. For example, if I look at this number line and I say, what is the coordinate of A? You just look here and you go, well, I'm looking at A. That is the coordinate. Oh, let me switch colors. Right here, I can see that it's at -2. It's almost like its address. -2 is the coordinate of A. It's where it is located on a number line. If I were to look at D, I go right here, and I could say 2 is the coordinate of D. I'm just looking at a number line. That is where it's located. Now, if I wanted to know the distance in between two things, first of all, if I start at 0 and I walk 10 miles, I know I've walked 10 miles. But let's pretend that I was walking, like here's where I'm going to start. I start right here and there's all these mile markers on the road. And let's say I started walking right here, and these are all miles, and I walked to the 10-mile marker. How many miles have I walked? 8. And you guys can figure that out because you go, well, if I started at 2 and I ended at 10, I have moved 8 spaces or 8 miles or whatever. And what you are doing is you are subtracting one thing from the other. So what we could do here is you can do this in one of two ways. Most people like to go, well, the distance between here is 10 minus 2. You don't have to do it that way. You can go 10 minus 2 is 8 miles. You could also do 2 minus 10. But then we get something different. What would 2 minus 10 be? -8. Now here's a problem here. I don't care what you do, you are about to win an award if you can wake up in the morning and run -8 miles. There is no such thing as a negative mile. You can move 0 miles, you can go 1 mile, you could go 1,000 miles, but running a negative distance, there aren't these things. So you're going to see in geometry, there's something interesting that happens. Like if you are measuring something and you're like, hey, the side of this triangle is -6 units long, something's wrong. That's not even possible. Like if I was measuring my height and I go, I'm -5'9", that's a problem. There's right away, you'd be like, I don't know if he's 5'9" or not, but that negative is a huge problem in there. He can't be a negative number. My weight can't be a negative number. My height can't be a number. These are things that are measurable, and in geometry, we measure a lot of things. So the distance there cannot be a negative number. So it's actually the absolute value of that, which is a +8. So you're going to see that if we want to find the distance between two numbers, just subtract them in any order you want, but take the absolute value of that. So you do 10 minus 2, you get 8. So we could do the absolute value of 10 minus 2. We would get a +8, and the +8, if we take the absolute value, is +8. If I take the absolute value of -8, I get +8. It fixes it for us. So the distance between two things, all you need to do is subtract the two numbers. If you end up in a negative number, you know there's something wrong with your distance, just make it the positive value. All right, so we start getting into things called postulates. And postulates are kind of like theorems, but these are a statement or rule that is accepted without proof. So you're going to hear me call things a postulate, and you're going to be like, what's a postulate? There are things that we just accept, and you don't need to prove it to me. I get it. There are some things that are so like ingrained in us, we don't need to prove it every single time. So the first postulate that we're going to learn is the ruler postulate. And it looks like this. It talks about a ruler, like really like a line there, is that the points on a line can be matched 1-to-1 with real numbers. For example, you see this on a ruler. Like you have a line, and all of these points match up with real numbers, just like on a number line does. When I do a number line, they match up so that we've got 0, 1, 2. All those points will match up with real numbers. That's just, when I say the ruler postulate, that's what I mean is that numbers match up with all these lines here. Once a coordinate system has been chosen in this way, the distance between any 2 points equals the absolute value of the difference of their coordinates. That's what I just said, is that I go, if I want to know, let's say that each of these is 5 units. So we've got 0, 5, 10, 15, 20, 25. It doesn't matter what the units are. Once I choose a unit, if I want to know how far it is from here to here, all I need to do is the absolute value and subtract the two numbers. Now, I don't care whether you do 5 minus 15 or 15 minus 5. You do whatever's best for you. They're going to come up with the same number as long as we use the absolute value. 15 minus 5 is 10. The absolute value of 10 is 10. It is 10 units apart there. There are 10 units in between those two things. So when we're trying to find the distance between 2 points on a ruler, we subtract. Like if I said, how far is it from the 3-inch mark to the 11-inch mark on there, what would you say? It's 8 what? Well, on a ruler, if I said from 3 inches to 8 inches, right? Because you can do that with subtraction. Now, some of you might just be, well, I know that 3 plus 8 is 11. You're still just doing a form of subtraction in your head. You're using addition to help you with that. So you're doing subtraction. And if you did happen to end up with a negative number, understand distances cannot be negative. You managed to make a negative distance, boy, did you just win $1 million award because you just rocked the entire earth. Everyone is going to be blown away at what you just did. So that would be impressive. All right. Adding segment lengths. When 3 points are collinear, what does collinear mean? On the same line. When 3 points are on the same line, you can say that 1 point is between the other two. So it would be fair that since there's 3 points here to say that B is between A and C. Now here's a common mistake that people make that would not be true. It is not okay to say that B is in the middle of A and C. Why is that different than saying it's between? Hold that thought. So tell me why it's not okay to say it's in the middle.
Because it's not like exactly in the middle, it's just in between the 2 points.
There's nothing that says that's exactly halfway between there. We're not saying that. It's between them. Right now, I could say that this trash can is between me and all of you. It's not in the middle of any of us right there. It is way closer to me than any of you in here. I would not say that this trash can is in the middle. I can say it's between. So you got to be careful with your words when you say things. So be real careful. When something is between you, it can be closer to me, it can be closer to you. It could be in the middle, but middle is a very specific thing. It is halfway between both points. So we have to be careful with our words here. I say that because a lot of people use the word middle, and I get very picky and I start knocking off points there. So here, we would say E is not between D and F. Why would I say it's not between there? What am I not doing here? Yes, sir? It's not on the line. We said this is when they are collinear, when they are on the same line. You might be like, but isn't it between there? Well, when we're talking about between, we're talking about on a line there. On that line, is it between there? No, it's kind of off to the side. So that's what, we got to get this terminology. There's a lot of words in geometry, and if you don't get them early, then you're playing a lot of catch up and you start to fall behind. So between, just somewhere in between those 2 points. All right, this one looks very technical, but you already understand this 100 times, and I'm going to show you in just a minute. First, I'm going to nerd out on you and tell you the nerd definition, and then I'm going to show you already know what this means. If B is between A and C, so notice that the point B is between A and C, then A plus B is equal to B plus C, A plus B, AB, the distance from A to B, plus the distance from B to C is equal to AC. So I'm going to show you that you already understand this, even though it looks technical. All right, so I'm going to make up some numbers here, and even if my numbers are wrong, you're going to go along with me. I'm going to walk across the room, and here's how I'm going to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm stopping right here at 10, okay? That's 10 spaces. So let's just believe it, I'm not trying to trick you on that part. Now I'm going to do something really weird. 1, 2, 3, 4, 5. How many spaces was it across the room?
15.
How would you get 15? Let's talk 15. Why did you guys all come up with that number?
You added 10.
I went 10 spaces, and then I went another 5 spaces, so the distance across the room must be 15, and that's all this says. If you take the distance of the first part, so this first part here, let's say that this was 10, and the second part of the journey was 5 more spaces, then the whole distance here must be those things added together. You have to add those things together. So 10 plus 5 means that this would be 15. Now, I just made those numbers up for an example. But you understand that if you add the parts together, you get the whole. I'm going to even do this one more way that's even more complicated to help you out here. So let's pretend, just for a moment, and that it's 20 spaces across the room, okay? For me to get to the other side, it's 20 spaces. Let's pretend that's the truth. 1, 2, 3, 4, 5, 6, 7. How long is that distance?
13.
How'd you get that?
You subtracted 7 from...
You knew that the whole distance there was 20. And I have already accomplished 7 of those steps. So what must be left? 13. So you're applying those same concepts. Like when you go on a road trip, it's 1,000 miles to get there, and I've already gone 200 miles. I must have 800 miles to go. And this is called the segment addition postulate. And sometimes you'll see me write it as SAP because it's very wordy sometimes to say segment addition postulate. The SAP, the segment addition postulate, says if you add up this part plus this part, well, then I know how far it is from A to C. So AB plus BC equals AC. The two parts, if you add them together, will equal the whole. So far, so good? You'll forgive me, I get up and I act things out all the time. I just find math. It's like, we can show this, why not? All right, so J is between I and K. What does that mean in just plain English?
That it's like not in the middle, but like it's in like there's I and K and then J's like in between.
Okay.
I'm not really like.
No, I got you. He's saying, here's I, here's K. J is somewhere in between there. Now, I may have drawn this diagram wrong, but that's generally what we're talking about. J is somewhere in between there. And we'll see in a minute, maybe my diagram looks wrong. But here's what we're going to say. It says that IJ, they mean the distance from I to J right here is 2x. That's how far it is from IJ. If I walk from I to J, how far have I walked? 2x. Okay, whatever that means. I'm going to zoom in here for a minute. And the distance from J to K, that means JK means the distance there, is 4x minus 6. Okay, so that's this distance right there. From J to K is 4x minus 6. The distance from I to J was 2x. And finally, they're already telling me that IK equals 30. The whole distance equals 30. They said, find the value of x. Using what I just did in front of you and walking across the room, let's turn that into some math nerd speak now. Let's take these two things and go, wait, what did he do up there? How does that relate to this? Because that's the same situation. How can I find out what x is? Remember, I said, you got something? Because I'd rather you say it than me.
Like, you can add the two formulas to get IJ and JK together and then solve for x then.
He's saying that, I think, and correct me if I'm wrong, if I were to take IJ and add JK, I would get IK. Well, you're like, okay, but what is that going to do for me? I don't know. Let's fill it.
Wait, no. I was saying to get, like, the formulas instead.
He's saying like X.
No, you're right. I'm just being like sarcastic when I say I don't know. You're actually right. You're 100% right. I'm just like, I don't know. Let's see what happens. Let's plug in exactly what he told us to do. IJ is 2x plus JK, which was 4x minus 6, is equal to IK. And what was IK? 30. Now, I don't know about you, but I feel like we could do something with that.
Yeah.
Okay? Talk to me. Combine like terms. What like terms do I have where I can combine? 2x and 4x is 6x minus 6 equals 30. Talk to me. What else can I do?
You can, you do the inverse.
Add 6 equals
6x is equal to 36. What next? Divide by 6 and x is equal to? 6. So we sure enough can. That is the segment addition postulate. But I kind of needed a little picture to help me out there. That I go, oh, okay. Now, if I said, give me a number for exactly how long IJ is. Remember, you just told me x is equal to 6. Exactly how long is IJ?
Well, you have to plug it in.
I have to plug it in. To what?
To 2.
Yeah, 2 times x, because IJ is 2 times x, and we know that x is 6, so how long is IJ?
12.
It's 12. How long is JK?
18.
Yeah, it's 24 minus 6, which is 18. And we already know how long ik is. They already told us that. So it better be true if we're checking this. You said 12 and 18. If I add 12 and 18 together, I better get 30. And sure enough, I do. So that is the segment addition postulate. You use it all the time, but we really never break it down in math that way. We never go, oh yeah, heck yeah, I could do that. Like I'm looking at that, that makes complete sense now. So we found the value of x, the value of ij, which was 12, and the value of jk, which was 18. I'm going to pause. Let's try the next one. So again, when we've got the word congruent, it means two objects that have the same size and the same shape. A square and a circle can never be congruent because they don't have the same shape. A little tiny circle and a big circle can never be congruent because they don't have the same size. So we're talking about two things that are basically the exact same shape. Same shape, same size. And when we talk about congruent segments, remember a segment is just a piece of a line. We're talking about two pieces of lines that are exactly the same length. And this is so super important. What I'm about to show you is like a big star because you miss it now, the future lessons you're going to be like, wait, where did that come from? You see that red line there? That red line means something in geometry. It means that this line, AB, when I put a red line on it like that, and I put the exact same red line on another line, CD, it means, I promise you, those two lines are congruent. They're the exact same size. I don't know what that size is. I don't know whether it's 20 miles, 20 inches, whether it's a centimeter, but I can tell you that whatever they are, they're exactly the same. Like, so if this is x, that's x too. X as well. It means they are equal to each other. They have the exact same length. AB, the length of AB is equal to the length of CD. We use that AB to represent the length of that line and CD to represent the length of CD. The congruency symbol looks like this. It is totally terrible in your notes, so I'm going to clear it up here. This is what the congruent symbol looks like. When we see this, it means that two things are congruent. It's an equal sign with a squiggle on top. When you see it, it means two things are congruent. Congruency means same shape and same size. Same exact shape, same exact size. So when I say that line segment AB is congruent to line segment CD, what I mean is we have two line segments that are exactly the same size. If one's 4 inches, the other one's 4 inches too. Almost finished. We only have one more slide, so we are flying along. All right, so let's play some always, sometimes, or never. This is kind of like true, false, but it's not like all the time. Some things can happen in certain situations. Sometimes will always happen. Sometimes things will never happen. So let's start off with the length of a segment is always, sometimes, or never negative. Never. You can never have the length of something that is negative. If point S is between R and V, so think about what that means. If point S is between R and V, then S lies on segment RV. Always. Because what we mean is we learned that if S is between R and V, we learned that that means that there is a line segment with R and V, and somewhere in between there, I don't know where, there's S, and that meets it. It lies on RV. That's always. A coordinate can always, sometimes, never be paired with a point on a number line. Yes, sir? When you say sometimes, if you say sometimes, then you have to give me the situation where it wouldn't happen. Yes, sir? Okay, but remember it said once you choose, it said, so it could be compared with on a number line. Okay, I'll go with that. I would say sometimes, and with his definition, that's good. He's saying that in a coordinate plane, what he means is this. I can't just put -6 on there unless I know whether it's X or Y. So they can be matched up with numbers, but so I'm going to put always because what they meant to say is that it can always be matched up with a coordinate plane. But you're right, that it can't always go on a number line. Like the coordinate 7, 4 can't go on a number line. That goes on a coordinate plane is what he's saying. So I hadn't thought about it like that. That's a great description. I would have said, yeah, of course they can be put on a number line, but only the ones, only the like single numbers, a single coordinate can be put on a number line. That's all we've got for today. We still have 10 minutes here, so I'm going to make a recommendation to you. We have 10 minutes, and I'm going to expect that you are working on your homework the rest of the time. I encourage you, I very much support you working with somebody else on your homework. Not because I want you to get answers from them. I want you to be able to bounce answers off of them. Be like, hey, does this sound right? No, dude, you got that totally wrong. Here, look, this is how you do that. So you're working together. But I do expect, again, that all the work that is on your paper is your work. Now, you guys can be like, yeah, is this how you do it? Okay, show me. And that's okay. I don't mind if two papers look exactly the same in terms of like you guys wrote the same things, but you guys got to understand the homework is here so that you guys will stay in the class. At some point, a lot of people end up leaving geometry honors because they feel they can't hang anymore. Trust me, stay with the homework and that won't be you. You be like, you're always doing your homework, you're not going to be in that boat. It's the people who start slipping on homework that I have traditionally seen that tend to go, I don't want to be in this class anymore, it's just too much.